All right. Here we go, guys. Here we go. Ready? So notes 20, concavity. So we're now going to start talking about the first, second derivative, how it relates to f. So we'll do the review where we need to. So quick, let's do something that we did yesterday really quick. So since some of you missed, so here's pretty much the gist of what we talked about yesterday. We're going to use the first derivative test to find local extrema. Extrema is just Latin. It just means local max, local mins. So the big deal was that if the derivative changed from positive to negative, f has a what? Max. And if f prime goes from negative to positive, f has a min. Remember, if f prime is positive, that means f is increasing. If f prime is negative, f is decreasing. Pretty straightforward, right? Okay, so, and I know I say here identify absolute extrema. This end behavior is x cubed, so it's not going to have absolute because x cubed looks like that, so it increases forever left to right. That's the end behavior, of course. This does decrease a little bit. How do we find where it increases or decreases? Take a derivative. So I go derivative, f prime of x. Derivative of x cubed is 3x squared minus 12. I'm going to do something called find critical numbers. I find critical numbers by setting the derivative equal to what? 0. So I'm going to factor out a 3, and you'll have x squared minus 4. And I guess you can also do difference of squares, but I'm just going to go ahead and just solve for it. X squared equals plus minus 2. Or x squared equals 4, and then square root x equals plus minus 2. Does that make sense, guys? Okay, then from there, I'm going to do a number line. Sometimes we call this a railroad track, so I'm going to call that f prime. I'm going to put negative 2 and 2. And maybe some of you guys already know, like Chav, obviously there's going to be plus minus plus because of the end behavior of x cubed. But let's test it out. I'm going to put a number to the left of negative 2, like negative 10, into the derivative, because I want to see, all you care about is positive or negative. Negative 10 squared is 100. 100 minus 4 is still positive, 96. Positive times 3 is still positive, so plus. I pick a number between negative 2 and 2, like 0. 0 squared is 0. 0 minus 4 is negative. Negative times a positive is a negative. And if I pick another number bigger than 2, like 10 or 20 or whatever you want to do, you're going to get another positive again. Cool or not cool? So at negative 2, f prime is changing from positive to negative. So that is a what? That's a max. So I'm going to write f has a max at x equals negative 2 since f prime changes from positive to negative at x equals negative 2. And I know it sounds funny to say it again, but that's where it changes signs from positive to negative. Now, at x equals 2, I change from negative to positive. So that is a what? Min. So I'm going to write f, because that's what f has the min, right? F has a minimum at x equals 2 since f prime changes from negative to positive at x equals 2. And there it is. That's pretty much everything we did. That's pretty much the gist of what we did yesterday, of what we learned. How do we feel? All right, so look at g of x. G of x says x squared minus 3 times e to the x, and I want to find max min. I want to find extrema again. So I'm going to go ahead and take the derivative. I'm going to do what rule? Product rule. So first, I know delta math does the other way around, e to the x times the derivative. It doesn't matter with product rule because there's a plus in the middle. But I like to do it this way. First times the root of the second, e to the x, plus second times the root of the first, 2x. And then you're like, man, how am I going to find the critical numbers there? Relax, you can do it with algebra. I notice that this product has an e to the x, and this product has an e to the x. I can factor out an e to the x. E to the x factored out, and I'm going to get x squared. And I kind of want to put the plus 2x first, minus 3. Can I do that, guys? Okay. I'm going to set this equal to 0 to find critical numbers. And you got to know a little bit about how to factor. It's not an extreme. It's not extreme. E to the x, and let's see, two numbers that when I multiply give me negative 3, but add up to a positive 2. Yeah, x minus 1. Positive 3 times negative 1 is negative 3, and positive 3 minus 1 is positive 3 minus 1 is 2. Cool or not cool? E to the x will never be 0, guys. Never be 0. A quick recap of how e to the x looks like. I'll write it over here. E to the x looks like this. So never be 0. The limit is 0 as x approaches negative infinity, but e to the x itself will never touch the y value of 0. Will never touch the x-axis. Cool or not cool? But this expression here will be 0 if x equals 1 and if x equals negative 3. How do we feel so far? I do my railroad tracks. It's not actually called a railroad track, guys. If you want to know the technical name, it's called a sign chart. But I call it, why did I start calling it road track? I think one of my football players started saying, oh yeah, railroad tracks. So, yeah, football players always, you like oh, whatever it looks like, that's what it comes to mind and that's what they say. All right, negative 3. So I pick a number to the left of negative 3. You don't care about positive or negative. E to the x is always positive because you're always above the x-axis. So all you care about is the sign. Did I say I don't care about positive or negative? I don't care about the number. I just care about whether it's positive or negative. So if I choose like negative 5, negative 5 plus 3 is negative. Negative 5 minus 1 is negative. Negative times a negative is a positive. If I choose a number between negative 3 and 1, like 0, I get 3 times negative 1, which is a negative. And if I choose a number bigger than 1, like 5, positive times a positive, which is a positive. I change from positive to negative at negative 3, so that is a max. And I go from negative to positive at 1, so that is a min. I'm actually curious to see how this looks. Let me see, negative 4, negative. Okay, we'll graph it right now to see how it looks. So x equals negative 3 is max since f prime changes from positive. What happened, miss? Oh, F.
It's G.
G has, so then this should not have been F prime, should have been G prime. G has max at x equals, man, let me see how I can write it now that I've already written it like this. X equals negative 3 is max on G. There we go. Since G prime, sorry guys, changes from positive to negative at x equals negative 3. And then what do I have at 1? X equals 1 is min on G since G prime changes. Don't worry, we're taking up some of the space from here, but we don't need all of it. G prime changes from negative to positive at x equals 1. And I'm curious to see how this looks. I'm going to type it into my calculator super fast. So now that I have it connected, I can just type it really quick, guys. So check it out. I'm just going to push y equals in my little app thingy. And I already forgot the equation. What was it? X squared minus 3, close it, e to the x. E to the x. And I'm going to push graph. And let me zoom out. Let's see. No, I'm going to click window. I'll make it custom. Negative 10 to 10. And negative 5 to 10. Bam. Sure enough, I can see 1, 2, 3. It's a max, just barely. You can see that it goes up right there until there. And then from negative 3 all the way to 1. Now, I need to go down a little more. Negative 8. Yeah, check it out. Cool, right, guys? Or not cool? Yeah, that's an absolute min, by the way. So, all right. That's pretty much what we did. Okay, here we go. Here's the big stuff. Hopefully we know what concavity means. We kind of already touched on it. I'm just going to draw this. This is concave down. This is concave up. I have a point of inflection right smack bam right there. Point of inflection. All it means to have a point of inflection is where concavity changes. That's all it means. Cool or not cool? Nothing crazy, right? Okay. Nothing crazy, guys. We haven't done anything crazy. All right, let's go to the next page. Now, here's the moment of truth. I don't want you guys to be a robot. Try, and I know it's late in the game already, but try to stay in the game here. I don't want you to be a robot. You can do this section being a robot, but try not to be a robot. I'm going to draw something that's strictly concave up all the time. That's always concave up, right? We're going to call that F. Cool or not cool? Now check it out. What is happening to F prime? So look, right here at that point, I'm going to put some points, some very special points. Just random points. I don't have any values. I just want you guys to observe. I don't want you guys to be a robot. So tell me what you think is happening to F prime. At the moment right here, it's a pretty large negative number, like, I don't know, -10, the slope, right? And then this one here, that's like not as steep, so maybe like -5. This one, everyone should know. What is that value of that slope? 0. And then this one, if I call that one -5, then that one looks like it could be like 5. And then this one looks like it could be like, I don't know, steeper, so 10. So tell me, you read the graph left to right, what is happening to F prime? It's increasing. That's the word I was looking for. Do you guys see that? -10, -5, 0, 5, 10. So we're going to say this. F, when F is concave up, or I guess should we say if? Yeah. If F is concave up, comma, F prime is increasing. Do we observe that? This is true. Always. All right, now let's see what happens. I'm going to draw concave down, something that's always concave down. That looks like an always concave down graph, right? And let's see what happens to F prime, my tangent. Let's see what happens to my slopes. My tangent slopes. I start off here. That looks, well, I don't want it to be, my parabola, my pretty parabola went away. Okay, here we go. I have a slope there. That looks pretty steep. I don't know, maybe 10, maybe 15. And then I put another point here. That's not as steep. Maybe it went to 5. Then right here, everyone should know that one. 0. And then here, if I call the one on the left 5, then that looks like a slope of -5 or -3 or whatever. And then this one looks like a slope of like -10. What is going on left to right with F prime? Perfect. If F is concave down, comma, F prime is decreasing. Are we okay? All right. Is this idea stuck in your head? Like, we got this for sure, definitively. Okay. All right. So then I say this statement. What conjecture can we make about F prime prime? So let's see. Let's see, guys. So think about it. If F is concave up, here's what we already said. We said that if F is concave up, that means F prime is increasing. That's what we said, right? Okay, well, how does that relate to F prime prime? No, F prime prime is not increasing. No. Man, guys, you guys are just saying stuff. You're not using your brains. What do we say? Okay. All right, let's slow down. Let's stop. No. Okay, stop. Because you guys are just taking guesses now.
Wow.
All right. Think about it. Let's just go back to the basics. What did you tell me when f prime was positive? If f prime was positive, what was happening to f? F was increasing because f prime was positive. Yes or no? Okay, now I'm telling you that f prime is increasing. What does that tell me about f prime prime? No, guys, listen to what we said. Okay, let's start again. Look, guys, listen. No, okay, look, stop with that word. For now, increasing is part of these words. Okay, look, guys, focus. You told me yesterday and today, right now, that if f prime is positive, notice what I just said. If f prime is positive, guys, focus. If f prime is positive, that means my tangent slope is positive. So you told me if f prime was positive, that f was increasing. That one's okay to say. That's true. That's true. If f prime is positive, you're going up. That's right. Now I'm telling you, look what it says. It says f prime is increasing. How does that relate to f prime prime? It's positive. It's the same relationship. It's the same relationship, guys. F prime is positive, f is increasing. Oh, now it's f prime that's increasing, so f prime prime must be positive. If f prime prime is positive, f prime is increasing. Because they're only a derivative away from each other, f prime and f prime prime. Mm-hmm. Does that make sense? Yeah. Do you guys know what I mean when I say positive?
No.
No? Okay. Draw a grid. Just a random grid. Actually, you don't even need the y-axis. You just need the x-axis. Draw a line, x-axis, and then I guess a dotted line if you want to put a y-axis. Everything that's above the x-axis is positive. That is different. This is positive. And everything that's below the x-axis is negative. The value. Like if you plot points. Now, okay, I guess we should talk about, let's go to Algebra 2. Let's talk, no, relax. Don't get mad, guys. Don't get mad. Okay, look, I'm going to draw some regions. I'm just going to draw some regions. Let's see, point A, point B, point C, point D, and point E. Do you guys see all those points on the x-axis? As a matter of fact, I don't need the y-axis. Let's get that out of there. Okay. Above that purple line is positive. Below that purple line is negative. Between A and B is this curve. Let's call it F. Is that curve positive or negative between A and B? Negative. But between A and B, am I increasing or decreasing? Decrease. So you're decreasing and negative. Between B and C, is the value of F positive or negative? Negative, because it's below the x-axis. But is that function increasing or decreasing? So you're increasing but negative. Between C and D, is this F positive or negative? Positive. Is it increasing or decreasing? Increasing. Between D and E, is it positive or negative? Positive. Is it increasing or decreasing? Decreasing. It's decreasing but positive. Do we see the difference? No. Okay, what's up, Wilson? Ask. Hit me.
No, I'm just making a thing.
Okay. All right, going back to this. You already told me that if f prime is positive, I'm talking about the derivative. If the derivative is above the x-axis, if it's positive, that f is increasing. Yes or no? Yeah, or I guess put the picture away. If f prime is positive, remember that means slopes are positive, that my f is increasing. F. So you see the relationship between f and f prime? Okay, now I'm telling you that f prime is increasing. If f prime is increasing, what does that mean about f prime prime? Not that it's increasing, that it is positive. This f prime prime greater than 0 means f prime prime is positive. F prime prime is positive. Does that make sense? Okay. How does f prime prime relate to f? If f prime prime is positive, f is concave up. But why, Chavez? Because if f prime prime is positive, that means f prime is increasing. And if f prime is increasing, that means f is concave up because we have a situation like this. Look, see these slopes are increasing. That's f prime. F prime is increasing. Does that make sense, guys? Okay, so don't worry, we're going to have a lot of practice. So there it is. So all these go together, and I'm going to color code it so you guys can have a good notes. If f is concave up, that means that f prime is increasing. If f prime is increasing, that means that f prime prime is positive. Cool or not cool? So how does it relate to f? Well, if f prime prime is positive, f is concave up. Cool or not cool? Cool. All right. So here we go. If you have colored pencils, this is a place to get a colored pencil. And I'm going to write, if f is concave down, what does that mean about f prime? Perfect. F prime is decreasing. That's what we saw up there. Now, if f prime is decreasing, what does that mean about f prime prime?
Negative.
It's negative. So this right here is the symbol for f prime prime is negative. How do we feel? Are we winning with that? Okay. Yeah, I know. In the beginning, it's tough, but after you do a whole bunch of practice, it's going to be super simple. So maybe I was too ambitious by putting a free response, but if we can do that free response now, you will be amazing. Okay, so look, I start off with something simple. Something simple. Does everyone know how y equals x squared looks like? It's a parabola. This parabola is always concave up, and it says use a concavity test to determine the concavity of the given function in the given intervals. So I have an interval here 3 to 10. Well, we already know it's concave up everywhere, especially 3 to 10. But let's see if it's true. Y prime equals 2x, and I'll take another derivative to see the concavity. Y prime prime equals 2. Is that always positive? Yeah, it's always positive, no matter what x value, because look, there is no x. It's always positive. Hence, y equals x squared is always concave up, especially on the interval 3 to 10. I guess if we want to answer the question, yes, it's concave up on 3 to 10 since the second derivative is positive. How do we feel, guys? Oh, what was that, a monkey? I just heard like, wow. Sorry, YouTube. All right, here we go. 3 plus sine x. All right, guys, focus. 3 plus sine x on 0 to 2 pi. Actually, you know what? We can actually just draw 3 plus sine x really quick. We know how sine x looks like. Sine x looks like this. I know. Before everyone comes and says, that's not 3 plus sine x. Let me just draw this part here. Boom. You're right. That's not 3 plus sine x. 3 plus sine x is a vertical shift up 3 from this one. Yes or no? Here's 0, here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. And everyone should know that because we've done, we've all taken pre-cal, right? Oh. I'm gonna put it way up here. Boom, boom, and then. Yeah, it doesn't have to be perfect. I'm trying to make mine perfect, but it's not going to be perfect. All right, let me see. Let's see how it came out. Well, let's see. Whatever. You know what I could have probably done? Let me see if it would have worked. Copy paste? Oh no, because I did it in 2. Maybe I could have done it. Yeah, I probably could have just and then translated. And let's see. Okay, next time. All right, whatever. Okay, here we go. Ready? Let's see. We already know just by looking at it. I know that I'm concave down between 0 and pi, and I'm concave up between pi and 2 pi. Do you guys see that? All right, so let's see if this is true by taking the derivative twice. Y prime equals what's the derivative of 3 plus sine x?
Cosine x.
Cosine x. And I need one more derivative, y prime prime. What's the derivative of cosine x?
Sine x.
Negative sine x. Chop, how are we going to figure this out? Like this. I'm going to equal this to 0, and I see that I only get one critical number between 0 and 2 pi. I get pi. And then here's my number line. That's 0, and here is 2 pi. And then I just put pi there, because that's a closed interval. And I'm going to say this is f prime prime. I'm just plotting f prime prime. Okay, think about the unit circle. We all had pre-cal. Sine x, because it says sine x is positive between 0 and pi. Do you guys agree? But then I have a negative in the front. So negative times a positive is a?
Negative.
Negative. Well, that was a good one, miss. Are we okay so far? Okay, sine between pi and 2 pi, I'm below the x-axis, so sine is negative, but negative times a negative is a? Positive. So look, we know that we're concave down between 0 and pi, and it verifies by this. I have a point of inflection at pi, and sure enough, yep, I have a point of inflection at pi. And then between pi and 2 pi, it is concave up. And yep, it verifies. Do you guys see that? So I'm going to write concave down on parentheses 0 to pi. Use parentheses when it's talking about concavity. Since y prime prime is negative and concave up on, let me erase this unit circle, on pi to 2 pi, since y prime prime is positive. And when I'm talking about concavity, I'm talking about concavity on y, or f of x if I call it f. How do we feel? Nothing crazy, right? Okay. Here we go. Oh yeah, we don't need, okay. I don't know if you guys recognize this number. I can already tell, look, they're already telling me that that number there is that 0.707, and it says find all points of inflection. So that means where it changes concavity. Cool or not cool? And I can already tell that I have concave down to concave up at that specific coordinate. Do you guys recognize that number? It's okay if you don't. You use it all the time in pre-cal. I think that's square root of 2 over 2. Yeah, look, let's type it in real quick. I can do it really fast.
I was just writing square root of 2.
Square root of 2 divided by 2. I mean, if you recognize that, that's cool. See? 0.707. But if you don't recognize it, that's fine. We're going to get it. Check it out. How are we going to get it? We're going to take the derivative how many times? Twice. Here we go. Y prime equals first derivative. The derivative of e to the negative x squared is itself, e to the negative x squared, times negative 2x. So there it is. I put the negative 2x in the front. Negative 2x e to the negative x squared. Cool or not cool? Now I'm going to take the derivative again, one more time. I have to use what rule? Product. Y prime prime equals first, negative 2x, times the derivative of the second. Well, the derivative of e to the negative x squared is this negative 2x e to the negative x squared. So don't do it again, just type it in like this. Plus second, I'll close the door right now. Times the derivative of the first.
You should slam it on purpose.
No. That's just...
Look at them slowly.
Bro, give them the down rifle.
Just don't.
In the class. You should have gone and shut their door.
Oh, they're just excited to learn, I guess. All right.
She was like,
We're like planning up the locker.
it's called for a second.
All right, here we go. You're done with calculus. Now it just looks like we're just going to be doing some algebra here. I guess let's make it pretty real quick. Negative 2x times negative 2x, that's a 4x squared e to the negative x squared minus 2e to the negative x squared. I'm going to factor out, let's see, what am I going to factor out? A 2e to the negative x squared. Oh, yeah, there it is. 4x squared minus 1. 4x squared minus 1. I'm going to set that sucker equal to 0 because that's where I have a sign change. Are we still okay? No, I'm just doing algebra, guys. I'm gonna set this will never be 0, but this will. So I set that equal to 0. I move the 1 to the other side. 4x squared equals 1. Oh, there's an error. Yeah.
Yeah, I was gonna say.
2. Yeah, you guys need to fix me. 2 and 2. Okay, from there, divide both sides by 2. And then what's the last thing I do? Square root. X equals plus minus 1 over square root of 2. When you rationalize this, do you get plus minus square root of 2 over 2? So that's where I have my points of inflection. That's that, and that's the other one.
So, can you explain how square root of 1 and 2 is equal to 1 over square root of 2?
Your exponent rules?
Oh, because
Square root of 1 over 2 is square root of 1 over square root of 2.
Square root of 2 is square root of 1 is just 1.
Yeah.
Right, my bad.
Well, you're good. How do we feel, guys? Are we okay? All right. Kind of tempted to. Yeah, open it. We have everyone here, though. Yeah, open it. Go ahead. Oh, it's America? Okay.
This is a lot.
Okay. We didn't do a sign chart on this, guys, because we can see it visually here, but I guess I'm being a little lazy there. There is a sign change for sure. You know what? Let's practice with our calculators. Let's practice with the calculators getting this number here. Type this derivative right here, this one, in your calculator. So I'm going to show it. Type the 4x squared e to the negative x squared minus 2e to the negative x squared. So here it is. I'm going to go to my calculator. I'm going to click y equals. And I'm going to type it in here. So what was it? 4
squared.
e to the and then what was it? Minus okay. So I'll wait for everyone. Here's what I have.
I can't find the X.
The x is next to the alpha. Where is it?
I found it right here.
No, use this one.
Oh, what's the difference?
It's fast.
Oh.
Yeah, it's an extra button. That's what Alvarez was doing earlier too. Did you forget about the X?
I did. I didn't know about it. Wait, where's the X?
No, you did, but then you forgot about it. Because remember we taught you last time? Because you were always pushing alpha.
Oh, maybe actually. Oh my god, I forgot my negative. Oh.
Does everyone know how to use their calculator, guys? Make sure you can push alpha X, but it's easier to just push X immediately next to the alpha. Okay. Before we start, does everyone agree this is your second derivative? Okay. So I want you guys push window. And I'm going to go from negative, let's see, from negative 1 to 1. And you only care about where you cross the x-axis. So on y min, make it negative 1. On y max, make it 1. And don't worry about the x resolution and all that good stuff. Push graph. Okay, so what you have here, right, I want to make sure that you understand what we're looking at. That's square, that's cube. What you're looking at is the second derivative. Yes or no?
Yes.
So to the left of this intersection, of that x-intercept, I'm concave up. In between these x-intercepts, I am concave down because the curve is below the x-axis. And to the right of that, I am concave up. So, yeah, that's why it's clicked on window. So, you change concavity. Points of inflection happen where you change signs, where the second derivative changes signs. So, it's going to happen at those x-intercepts. Those x-intercepts are 0.707 plus and minus. I'm going to show you how to do that. Okay, and if yours does not look like this, click on window. Okay, Ms. Guerrero, click on window and put negative 1, 1, negative 1, 1. For x min, x max, and y min, y max.
So we messed up.
X scale 1, y scale 1, leave x resolution alone. Okay, here we go. Is everyone here? Push second calculate. The calculate button is a trace button.
Oh my god.
These are all the options that it does for you. I'm going to click on the 0 because I'm looking where I cross the x-axis. The 0 means where the y value is 0. So I'm going to push 2. And then it says left bound. So it's telling me, where do you want me to look? So I'm going to click the left arrow until I see it. So come on, look. So there it is. And I just go to the left of that x-intercept. Push enter. You don't have to go extreme. You just go to there. It says right bound. Go to the right of that x-intercept. Push enter. And it's going to say the word guess. If there's many of them, go to the one that you want. There's only one, so you don't have to push anything. Just push enter. It needs to say the word 0. Does it say negative 0.707? That is a point of inflection at that x value. Let's try it again. Let's practice again. This time with the one on the right. Obviously, it's going to be the same value, but positive. Second, calculate number 2. And it says left bound. Oh, wait, I'm going to scroll all the way. So you can actually just push the number 0.5 if you want to get there really quick. So I'm going to go right there. Left bound, 0.6. Right bound, I'm going to scroll to the right of that. Push enter. Guess, I only have one intercept, so I don't care about guessing. Push enter again. Does yours say 0.707?
Yeah.
Those are my points of inflection. Cool or not cool? Cool. All right. All right. What happened over this? Dime, tell me.
Honestly, I said I've probably definitely done this on like an SAT or something.
Okay. All right, here we go. So we're getting closer and closer to real AP questions. Example 4. The graph of the derivative of a function f on the interval -4 to 4 is shown to the right. So what graph is this? No. What graph is this, guys? No. Don't tell me the function because it's the derivative graph. So plug in f prime in there so we know that we're looking at f prime. Yeah, it's too hard to figure out what type of function it is. So type that in. Put f prime there, guys. Label it so you know that you're looking at a derivative graph. Answer the following questions about f. Justify each answer with the information obtained from the graph of f prime. Okay, so here we go. You guys ready? On what intervals is f increasing? From -4 all the way to 1. Why? What's positive? Don't say the word it.
Oh, because it's concave up.
No.
F prime is increasing. Which
We want to know where f is increasing.
F prime is positive.
F-
F is increasing.
Perfect. So here's how you say it. F is increasing on the interval. You increase and decrease on a closed interval. On the interval -4 all the way to 1. Notice that I closed it. Since f prime is positive, that's how you say positive. On the interval -4, the -4 you can include it because you're way up here. And then, so look, it's not always positive. It hits 0 for a moment, but it's still increasing because the definition of increasing is that the next pixel is higher than the other. So -4 all the way to -2, parenthesis like that. And -2 all the way to 1. Period. Does that make sense, guys? Yeah, you have a one horizontal tangent right at -2, but then it continues to increase. What's up?
Why didn't you include 1?
What are you talking about?
So it's like from -4 to -2, you included -4, but
I didn't include -2. That's a parenthesis.
I meant like you include -4, but on -2 to 1, you didn't include 1.
Well, because at -2 and at 1, f prime is 0. And I'm saying that f prime is positive. I guess if I put the equal sign in the bottom, I couldn't put a bracket on -2 and 1.
Oh, I just meant 1 because it's like, because you included.
I don't know what you're talking about.
You said like f is increasing on the interval -4 to 1.
Yeah, it is.
Those are included, but then on the bottom you don't include. Well, that's
You increase or decrease on an interval.
Like that's just in general.
On a closed interval. You increase or decrease. The definition of increasing is that you're moving up left to right. Right at the pixel at -2, you're right on the x-axis, and then the pixel immediately to the right of -2 at -1.9, it's already higher than the pixel at -2. The derivative at -2 and at 1 is 0. Look, this says f prime is greater than 0, but I can't include it. Do you know what I'm trying to say? Okay. It's kind of like the graph x cube. X cube is increasing the entire domain, but right at 0, I have a horizontal tangent. Okay, all right. On what intervals, all right guys, focus. On what intervals is the graph of f concave up? They want f. Where is f concave up? I don't know how f looks, but can I figure it out by looking at f prime? Where is f concave up? Where f prime is increasing. Where is f prime increasing? -2 to 0. Yeah, it's a little off, but -2 to 0. Where else? And 3 to 4. So you're going to write f is concave up on the interval. Now, concavity does have open. Don't put brackets on concavity because the point of inflections are not included for concave up and concave down. Do you know what I mean? So f is concave up on the interval. And you guys told me from what to what? -2 all the way to 0. Put parentheses on those. And where? 3 to 4. Since f prime is increasing on those specific intervals. You can also put in parentheses, f prime prime is positive on those specific intervals. The better answer is f prime is increasing because they give you the graph of f prime. You always want to use the graph they give you. Cool or not cool? What do you think, Guerrero? You okay? Okay. All right. Okay. I think we're doing okay, guys. This one could be trouble, maybe, if we include our endpoints. All right. Let's see if we can find at least one of them really fast. At what x coordinate does f have a local extrema? Okay. Give me a maximum really fast. Where does f have a local max or a max?
-4.
No, I actually have a min at 0. Not at 0. F. The f prime has a max at 0, but not f.
It goes from positive to negative.
Okay, so where? 1, yeah. Is this graph f prime? Where am I going from positive to negative? At 1. So, f, make sure that we're specific, guys, because we're specific. F has a max. You can say the word local max if you want. F has a max at x equals 1 since f prime changes from what? Changes from positive to negative at x equals 1. And I know it sounds funny to say it again. Okay. There's 2 more that are local mins, but it's okay if we do not get it. Remember that we always have to test our... When I do this, what am I doing? Am I just... You don't know what... No, not railroad tracks. Okay. So, no, it's okay, because I think this is the first time I maybe done that sign. Whenever you see me do this, I'm talking about endpoints.
Oh.
So, yeah, the endpoints. I'm not trying to fly. I'm not like, So, you got to check your endpoints. So think about it. Though you're gonna have to think really hard. I'm talking about f. I'm not talking about f prime. At -4, f starts to. Remember, you regret left to right. At the endpoint -4, does f start to increase or decrease? No, f prime decreases. F prime is positive,
Still on the positive half.
so it's increasing. So that means at -4, that is a. Is it a max or is it a min?
Min.
It's a min. In case you're wondering, like, Chav, I don't understand. I need a visual. Look, I'm gonna get you a visual right now from your last notes. I'm gonna get you a visual right now from your last notes. Written notes. Look, it's this idea, guys. I know that, yeah, you guys were out, so you might have issues. But look, we'll give you a visual really fast. It's this idea right here. Make sure to look at this whenever you get a chance, because it's right. Where are you? Is it right here? Look, it's right here. It's this idea. let's look at the left one. Look, at the left endpoint, if my derivative is negative, that's a max. But my derivative is not negative. Didn't we say that my derivative was positive? So look, here it is. At the left endpoint, here's my left endpoint. My derivative was positive. Boom, it goes up. That's f. So that has to be a min. Do you see that idea?
Yeah.
Okay, and then what about my right endpoint? My right endpoint, let's say, what about at x equals 4? Look, the derivative is negative right before I get to 4. So if the derivative is negative right before you get to 4, at x equals 4, that's what? It's a min. Think about it. You're going down, 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 down until you hit 4. That's these notes. Look, make sure to look at it, guys. Look, it's right here. At a right endpoint, if the derivative is negative, look at that. Boom, you're down there. The derivative is negative. You keep going down, bam. That's a min. Do you see how the right endpoint's a min? Cool or not cool? Cool. So I'm going to put, for now, I'm okay with you guys. Well, I'm not okay, but I'm okay if we get, if we're kind of confused on that. I'm going to put here min at x equals negative 4 and x equals 4. And I guess I'll put a reason why, right? So at left endpoint, comma, f starts increasing. So visualize that at your head. At right endpoint, how should we say it with English words? F decreases towards right endpoint. F decreases as it approaches right endpoint. I don't know if those would, actually I do know. I don't think this would be sufficient enough to get full credit on those endpoints. But for now, we're going to leave it like that because it makes sense to us with what we know. I don't want to hit you too hard just yet. Are we okay? Okay. But for sure, we got the one in red, right? F has the max at x equals 1 since f prime changes from positive to negative. Okay. If you got that one thing today and concavity, the idea of concavity, you're ahead of the game. Cool or not cool? Okay. Check it out. What are the x coordinates of all inflection points on the graph of f? Inflection points. That's where concavity changes signs. So where does concavity change signs? Whenever f prime changes from what to what? Well, that changes signs for f prime. Increasing to decreasing on f prime. Yes or no?
Yeah.
Okay, so where do I change from increasing to decreasing on f prime?
0.
At 0, but there's a one before that though. Negative 2, 0, and where else? There's one more. And 3. So there it is, guys. So you're going to say f has points of inflection at x equals negative 2, comma, 0, comma, and where else? Negative 2, comma, 0, and 3. Since f prime changes from, and always take the first one that changes. It changes from what? Left to right. It changes from decreasing to increasing. From decreasing to increasing. And vice versa at those specific x values. That would be full credit. That would be full credit if this were a real APA exam. How do you feel? Okay. Letter E, if you try really, really hard to be a robot, letter E can be really hard. Don't make it hard. There's only 4 types of graphs. There's only 4. So before we get started, let's talk about the 4 different types of graphs there are. You guys ready? You can increase in 2 different ways. You can increase concave up. You can increase concave down. So let's see. I'm going to draw both scenarios. You can increase concave up. Here's how it looks if you increase concave up. Here's how it looks if you increase concave down. Do you guys see that? That's it. That's it. For increasing, you can either increase concave up, increase concave down, and I guess you could also say increase with no concavity, which is just a linear line. Cool or not cool? Okay, for decrease, You can either decrease concave up. Let's see, how does that look? Decrease concave up. Or you can decrease concave down. Do you guys see that? Okay. They do not tell me what my initial value is. We're getting really close to being able to do antiderivatives and all that good stuff, but they don't tell me an initial. Yeah, we're so close, guys, to putting all the ideas together. I'm so excited. They do not tell us where we start, but we can start wherever we want. So I'm not going to put a y-axis. I'm just going to put an x-axis. So here's my x-axis. And I'm just going to put the major numbers. Let's see, at -4. So remember, there's only 4 types of graphs, right? Okay. So I notice from -4 to -2, I notice that f prime is positive and decreasing. Cool. So I'm going to put -4 right here. And I'm going to put, let's see, how much room do I need? I'm going to put -2 right there. Okay. Let's go slow. If f prime is above the x-axis, if f prime is positive, that means that f is what? Increasing. But f prime is decreasing, which means f is what? Do you know what I'm trying to say? Okay. Okay. Let's talk about concavity. If f prime is decreasing, what's the concavity of f? Concave down. That's what you guys told me, right? But you told me f prime is also above the x-axis, so that means it's concave down because f prime is decreasing, but f is also increasing. So increasing concave down. So from -4 to -2, start wherever, do an increasing concave down graph. Doesn't have to be perfect. Increasing concave down. Boom. Right at -2, by the way, you have a slope of 0. So it's going to look something like that. It doesn't have to be perfect. Do you see how we did an increasing concave down graph? This I'm graphing f, by the way. This is f. Okay. Are we okay so far? Yeah. All right. Let's go back to f prime. From -2 to 0, I notice that f prime is above the x-axis, so that means f is what? Increasing. And I notice that f prime is increasing, which means f is concave up. So you're going to draw increasing concave up from -2 to 0. So I'm going to say zeros right here. Increasing concave up. So increasing concave up. Increasing concave up. So there it is. I wish I would have put more concavity in it, but that's fine. It does look concave up and it is increasing. Do you guys see that? Okay, then I go back to my f prime. And I go from 0, let's go from 0 to 1 first. From 0 to 1, f prime is above the x-axis. So that means I'm still increasing f. F is still increasing. And f prime is decreasing, so that means f needs to be going concave. So you're going to draw increasing concave down. And we observe that at 1, the slope is 0 because f prime is 0. So increasing concave down. I'm going to say 1 is right here. Increasing concave down. Let me put the 1 up there so it doesn't mess with it. Increasing concave down. Boom. Slope of 0. Okay, looks pretty good. Looks pretty good. Oh, maybe I should have put more concavity in it. You know what? Let me put more concavity in it. It doesn't have to be perfect. Increasing concave down. Perfect. Okay, we still okay? Okay. All right. So now between 1 and 3, f prime is negative, so that means I am decreasing. F is decreasing, and f prime is also decreasing, which means f is concave down. So decreasing concave down until you get to 3. So I'm going to say 3 is like right here. Decreasing concave down. Decreasing concave down. Boom. So there it is. And then, so I go back. I notice that at 3, now f prime is increasing, which means that my concavity is going to be up, but f prime is still negative. So I'm still decreasing, but concave up. Does that make sense? And at 4, notice that f prime is 0. So at 4, you have a horizontal tangent. So what did I say? Decreasing, but concave up. So here it is. Decreasing, concave up. And right at 4, horizontal tangent. There it is. We did it, guys. Wow. It's hard, but can you do it? You just got to go slow, and remember, there's only 4 types of graphs. There's only 4 types of graphs. Okay. I think we're doing good. I think we're doing good. Are you guys okay? All right. So now, remember that question when we did linearization? I know, guys, we're doing a lot of ideas, but we're putting them all together. And I threw you a bone here. This is a question, the same question from the very first example. But we'll talk about it right now. Okay. Are we okay so far? Remember when we did linearization and we said we don't know enough yet until we cover second derivatives and we're not there yet? Well, here it is. So look, relax. The ideas are very simple. Look what it says. If my derivative is 0 and I am concave down, then I have a max. Let's draw a visual. Can you get this right being a robot? Yes, but don't. If my derivative is 0 and I'm concave down, okay. Concave down. And oh, look at this critical point. I'm going to call that C. Oh, look. At that critical point, bless you squared, bless you cubed. At that critical point, my derivative is 0. Do you guys see that? I have a horizontal tangent right there. Cool or not cool? What's the concavity at C? No, it's concave down. So my second derivative is going to be no. Okay, yeah, let's okay. Guys, remember, I'll put it over here. F is concave down if f prime prime is negative. That also means f prime is decreasing. That's what we talked about earlier. F, and a bullet, f is concave up if f prime prime is positive. That also means f prime is increasing. That's the big idea today. That's a huge idea. That's a big idea, miss. Man. That's right. That's right. I'm kidding, miss. All right. Are we okay? All right. So here we go. Let's do it again. Let's talk again. This is F. Is F concave down? Yeah, it's always concave down. So that means my second derivative at C is negative. And notice I have a horizontal tangent right at C. So I have a critical point. So at that critical point, if you're concave down, that critical point must be a max. It must be. Look, it's the highest point. Does that make sense? So I'm going to write hence, comma, x equals C must be a max. And let me change colors. And I'm going to try to color code it. Look, if my critical point is 0, if I have a critical point, and I am concave up at that critical point, then it must be a min. Why? Because think about it. You're concave up, and you have a horizontal tangent. So it looks like this. So look, I color-coded it, guys. So check it out. Here is, I don't even need a grid. Here's my point C. And check it out. Is this concave up? Yes. So this is what's happening. F prime of C equals 0. Chav, why? Because look, I have a horizontal tangent. That's the definition of a critical point, where the derivative is 0 or undefined. And notice, is it concave up at C? Yeah. If you're concave up at that critical point, it must be a min. That's the lowest point on this curve. It's the lowest point on this curve. Hence, x equals C must be a min. It has to be, guys. Does that make sense? There's your visual right there, guys. Yay or nay? Okay, now look. We already know this question, example 5, is the same example from example 1. So I did that on purpose. It's the same one, guys. We know that a negative 2, look, my first derivative is changing from positive to negative, so I know that at negative 2 I have a max. Yes or no? I know that at 2 I have a min. So would you ever use a second derivative test for this? Probably not, because you'll probably use the first derivative test. But let's do it. Let's see. So I'm going to write f prime of x. I'm finding my critical numbers first. 3x squared minus 12. I'm going to set that equal to 0. Factor out to 3. X squared minus 4 equals 0. X equals plus minus 2. Those are my critical numbers. Critical numbers. Are we okay? All right, next. I want to know, is that critical number a max or a min? I want to know. So I go, okay, let's try -2. F prime prime of x equals, I'm taking the derivative again of this, the 3x squared minus 12. What's the derivative of 3x squared? 6x. So I go f prime prime of -2. I get 6 times -2, which is -12. That's a negative number. So think about it. Since f prime of -2 equals 0, and f prime prime of -2 is negative, so think about it. If it's negative, you're concave what?
Down.
Concave down. So do a visual. Get your little hand and do a little visual, like, oh, concave down, critical number. It must be a max, comma, x equals -2 must be a max on f. That's not the value of the max. It just must be a max. You have a max at that x value, at that x coordinate. Cool or not cool? All right, now let's try the other one, the x equals 2. So I'm going to go x equals 2. I already know that f prime of 2 is 0. So I'm going to write f prime prime of x. We already know that's 6x. F prime prime of 2 is 12. 12, that's a positive. So let's think about it. I'm going to write since f prime of 2 equals 0, and it has to be both of these conditions, and f prime prime of 2 is positive, take your little hand, go, okay, concave up, there's your critical point. That critical point must be a min. Since, comma, x equals 2 must be a min on f. And that's the same, so those are the same answers we got when we did problem number 1. How do we feel? Okay. Do you think we can do a few more? Or do you think we're getting pretty close to, yeah, you know, we already went this far, might as well, right? Okay. Yeah, I'm sorry, guys. I'm sorry. We'll try not to do this too much to you guys. All right. You might not have enough experience for this one, so let's go ahead and see what we get on this. True or false? If the second derivative is 0, then it's always a point of inflection. What does your gut tell you? You're going to say true? You say false? Yeah, I don't know. I don't have enough experience. All right, well, let's see. Let's see. Do you agree that x to the 4th looks like x squared? It's like, it look, you know, it does. X to the 4th looks something like this. Yeah, it looks like x squared. And that's always concave up, isn't it? Okay, well, look. F prime of x equals 4x cubed. F prime prime of x equals 12x squared. If I equal that to 0, I get a 0 at 0. So f prime prime of 0 is 0, but just does it ever change concavities? So this is false. Point of inflection, the second derivative has to change signs. Sometimes it will equal 0, sometimes it will not. Cool or not cool? Okay. Yeah. Yeah, I'm going to say false and just put f prime prime must change signs. And we're assuming that f is continuous, right? Assuming f is continuous. Okay. Cool or not cool? Okay. If f prime is 0 and f prime prime is negative, then fc is a local max. Okay, well, we just did that. That's the definition. So think about it. If your second derivative is negative, that means you're concave what? Down. And I have a critical point. So there's my critical point. Is that a max? Yes. Yeah, that's the definition of max. Definition, true. Definition of max. And I'll draw the picture. Here's my critical point. So there it is. If I call that C. So f prime of C equals 0. F prime prime of C is negative because you're concave down. Focus, miss. Okay, are we still okay? All right. So I know, guys. I know. We're. But let's keep going. The x-coordinate of the points of inflection for the graph of this are. So here we go. I'm gonna find the derivative. I'm gonna take the derivative how many times? Twice. And then I'm gonna set it equal to 0 because this is a polynomial function. So the only way that I'm gonna have a sign change is if I cross the x-axis, the 0 value. So here we go. Y prime equals the derivative of x to the 5th is minus what's the derivative of 5x to the 4th? Plus 3. Am I done? Take another derivative. What's the derivative of that? Perfect. Equal that sucker to 0. Chav, I need a calculator. No, you don't. Factor out a 20x squared. You will get x minus 20, 40, 60. 3. I get two critical numbers. I get, well, actually, I can't call it a critical number because by definition, critical numbers is where the first derivative is 0, not second derivative. Dr. George got mad at me when I said second derivative equal to 0. I was like, that's not the definition. Like, okay, we're being technical. All critical means is something's happening. So, you know, some people are super technical, some, it's not a big deal. Who cares? Just agree with them and be like, okay, whatever. All right. X equals 0, x equals 3. There's something happening on those. Maybe. Don't answer letter D just because you see 0 and 3. Here's my sign chart. Railroad tracks. Call it F prime prime. Put 0, put 3. And I put arrows because my domain is all real numbers. If you see brackets, that's because my domain is restricted. Or parentheses. All right. You don't care about the 20x squared because the 20x squared will always be positive. All I care about is that x minus 3. If I choose a number to the left of 0, like -1, -1 minus 3, positive or negative? Negative. If I choose a number between 0 and 3, like 1, 1 minus 3, negative. If I choose a number bigger than 3, like 5, 5 minus 3, positive. I only have one sign change. Where is that one sign change? At 3. That's the only sign change I have. So that's it. That's the only one. That's the only time the second derivative changes from negative to positive. Cool or not cool? Cool. All right. Flashback from note 17. I don't think you have this part, so do you want to add it real quick? Is this approximation an over approximation or under approximation? Yeah, add it to your notes really fast, but I don't think I put that in there. No. Like, you see, like, see, I don't have that. Is this approximation an over?
Oh, the question?
Yeah. Yeah, I stopped yours at the question mark. Yeah, we'll stop here at this example. We'll stop at this example, and then tomorrow we'll finish up that FRQ that we have down there. We're gonna do this. Yeah, we're gonna do this one. This will be the last one.
Thank you. My head hurts.
All right, this will be the last one. So linearization's coming back. It's not hard to do. Hopefully you remember. They want you to find the tangent line at x equals 1. So let's plug in a 1 into this. So 1 to the 1/4 is 1, and 1 times 5 is 5. So there's my point. And now I gotta get a derivative to find my slope. So f prime of x equals 5/4 x to the negative 3/4. I'm going to leave it like that because it's a 1. If it was a different number, okay, fine. I'll go ahead and change it. 5/4 x to the 3/4. Okay. F prime of 1. F prime of 1, I plug in a 1. 1 to the 3/4 is always 1. 1 times 4 is 4, so 5/4 is my slope. Does everyone see how I got the 5/4? Okay. Do you guys even know what I'm doing? Because maybe I didn't even read the question. Okay, let's look at the question. Let f be the function given by, and I got a function. What is the approximation for f of 1.1 found by using the line tangent to the graph of f at x equals 1? Is this approximation an over approximation or an under approximation? Justify why that is. So remember we did this a few days ago where we used the tangent line to approximate values. So what do I need? I need a tangent line. So I know, guys, I know this is hard, but because we pushed you guys pretty hard today. So here we go. Here's my tangent line. Y minus 5 equals my slope, 5/4, parenthesis x minus 1. Cool or not cool? This is what I'm using to approximate f of 1.1. Yay or nay? All right, here we go. F of 1.1 is approximately 5/4, parenthesis, 1.1 minus 1, close it, plus 5. Is that bringing memories? Okay, so let's see what that is. 5/4, parenthesis, 1.1 minus 1 is 0.1, and 0.1, isn't that the same as 1/10? Plus 5 equals, let me see, 5 goes into 10 twice. So I see 1/8 plus 5, so 5 and 1/8. 5 times 8, 40, 40 plus 1, 41. 41/8, that's the approximate. Or 5 and 1/8, whatever that is. Or 5 and 1/8. Okay, they want to know, is this approximation an over or an underestimate? Now that we know about concavity, I'm going to see what the concavity is at 1. If I'm concave up, so let's think about it, guys. If you're concave up, is the tangent line above the curve or below the curve? Below. If you're below the curve, is the approximation over or under? Under. If it's concave down and the tangent line, is the tangent line above the curve or below the curve? Above. Is my approximation going to be over or under? Over. Do you see what's going on?
Yes.
Okay, so that's the idea. I'm going to take a second derivative at 1. So I'm going to go f prime prime. And so that's why I'm going to start from this one right here. So 5 times -3 is -15 over, and then 4 times 4 is 16, x to the 4, 5, 6, 7, -7/4. And if you want to bring that down, you can. -15 over 16, x to the 7/4. And then I'm plugging in, yes, what happened?
That's ugly.
I know, a little bit. It's because I should have put more space. All I'm doing is plugging in a 1. I just care about, is it positive or is it negative? If I plug in a 1, I get a -15 over 16. That's negative. So what is F? Concave up or concave down?
Down.
Concave down. Because you're concave down, the tangent line is above, so it is going to be a over approximation. Does that make sense? So you're going to say, since... you know what? Let's just go right to the answer, because we're all tired. You're just gonna. What do I mean? I mean this. Tangent line lies above curve. Above curve, above f of x, or above curve, and I'll put in parentheses f of x, comma, hence, comma, approximation. Approximation is what? Over approximate. And then in parentheses, I'm going to say y. I'm going to write f prime prime is negative, comma, meaning tangent line is above. And I'm going to draw a little picture. Something like, see? So no, all the y values are bigger than the curve. Cool or not cool? Do you feel like we gained a lot today?
Yeah.
Okay, there is a delta. Relax. I at least look at it tonight. That's why I put down here. Look how ambitious I was today. If you go all the way to the last, notice that I didn't put due today. It says, all right, we have a delta math, a UH quiz, and a circuit. Don't worry, we're not going to do it all in one day. Notice that I didn't put that the delta math is due today. What does it say? Attempt today. At least look at it. At least try and get 2 or 3 questions out of the way. At least invest 20 minutes, guys. Do you have 20 minutes today to invest? At least 20 minutes. If you can invest 20 minutes, that's good. So at least do 20 minutes, do one. See how much you can do in 20 minutes, put a timer. Whatever you do in 20 minutes, that's good enough for now. Cool or not cool? All right, that's it, guys. We're done for today. We'll continue tomorrow. So it says, let f be the function given by, and they give you a function. What is the approximation for f of 0.9 found using the tangent line to the graph of f at x equals 1? So the first thing you got to do is find a tangent line. So what do you need for a tangent line? So I'm going to find my point. I'm going to plug in a 1 into that. So I'm going to write f of 1 equals -3, parenthesis 1 to the -5/2. 1 to any power is just 1. So 1 times -3 is -3. Well, I shouldn't say any power because not to the, okay, whatever. For this situation at this level, yeah. So I get -3. Are we okay so far? All right, so now that's my coordinate, 1 comma negative 3. Now I need a slope. I get a slope by taking a what? Derivative. So here we go. I'm going to write f prime of x equals negative times a negative is a positive. 5 times 3 is 15 over 2x. And I'm going to subtract 1. So the denominator is 2, so just make it 2 over 2. 5, 6, 7. So negative 7 halves. Are we okay? And then if you want to move that 7 halves down, that's fine. 15 over 2, x to the 7 halves. I'm going to plug in a 1. F prime of 1 is equal to 15 over 2, because 1 to any power is 1. Are we still all right? All right, so there's my slope. So here's my tangent line. I'm going to write y plus 3 equals 15 over 2, parenthesis x minus 1. Obviously, it doesn't say y plus 3 there. It just says y. So just move the 3 to the other side. That's the easiest way. You don't have to distribute anything, guys. As a matter of fact, I wouldn't distribute anything. 15 over 2, x minus 1, close it, minus 3. That's what I would type in here. 15 over 2, parenthesis, x minus 1, minus 3. I don't remember if delta, like the key, has it like that as well. They might. I think they might. I don't think they distributed it because they want f of 0.9. So their answer key probably has that 0.9 immediately substituted in there. So here we go. If I want the approximation of f of 0.9, f of 0.9 is approximately 15 over 2. And I prefer fractions. So 0.9 is the same thing. Well, 0.9 minus 1 is like, what's that, negative 0.1? So negative 1/10. Did I do that correctly? Minus 3. So, okay, so let's see. I see a 15 and a 10, so I like to reduce these, 3 and 2. 5 goes into 15 3 times. 5 goes into 10 2 times. Is everyone okay with that? Okay. So let's see what I see. 3 times 1, so a negative 3 over 4 minus 3. So negative 3 and 3/4. I would not write it like that. 3 times 4, 12, 13, 14, 15. I would write it as negative 15 over 4. So I would put negative 15 over 4, or you could also put, bless you, negative 3.75. Which any one of those two would be okay. Cool or not cool? And then it says this funny stuff when blocked, and then notice it says the second derivative. So let's take a second derivative. So we're gonna start from this guy right here. So I'm gonna write f prime of x equals positive times the negative is a negative. What's 15 times 7? 105? Okay, whatever you guys say. Over 4 x to the negative 9 halves. I think it might be, is it? Okay, perfect, we're good. Let's see, is it positive or is it negative? Positive times the negative is a negative. Now notice my point of tangency is a positive value. So what they're going to have here, they're going to have intervals. It's either going to be x greater than 0 or x less than 0. So x equals 1 is bigger than 0, right? So I'm going to put when x is greater than 0. The second derivative, notice that, remember, we're still plugging in a 1. If I plug in a 1 in there, do I get a positive or a negative? Negative. So as long as x is greater than 0, f prime will always be negative. Do you guys see that? So I put second derivative is negative. I'm pretty sure, well, I took a screen capture, so I'll show you what I wrote. Meaning the graph of f is concave what? Concave down. Now, if you're concave down, that means the curve, or f, is like that, and the tangent line is above. Does that make sense? So if your tangent line is above the curve, is approximate an over or an under?
Over.
An over. Over approximate, and then you submit. And then it's going to say, it's going to give you the green check mark. So here's what I typed. And we did get the green check mark, or I did get the green check mark. I typed that, and see for x greater than 0, f prime. You can't really see it, but if you zoom in carefully, it does have 2 primes in there. Do you guys see those 2 primes? It's less than 0, meaning the graph of f is concave down near the point of tangency, making the value an over approximate. Now don't be a robot, because you can't be a robot and get all these correct. Do we know why it's an over approximate? Because the tangent line lies above the curve, lies above f of x. Cool or not cool?
Yeah.
Cool. So I think when you get to that, you'll be able to kill it. Okay. All right, let's go to notes 20 now. So I'm excited, guys. This is a real AP question that they had last year. We can actually do most of it already. If you put a lot of thought into it, you might actually be able to do letter D as well. but well, we're gonna skip letter D for now. Let's read it and see what it says. The function f defined on the closed interval -2 to 8 and satisfies f of 2 equals 1. The graph of f prime, the derivative of f, consists of 2 line segments and a semicircle as shown in the figure. Okay, so there it is. Letter A. Does f have a relative minimum, a relative maximum, or neither at x equals 6? Give a reason for your answer. What would you write?
So it's concave up.
Yeah, it's just asking if it's a min.
Is it a min? It's a min.
On f, I'm not talking about a derivative min on f prime, a min on f.
Oh.
It says f, guys.
Wait, it's going from.
This is F prime. Negative positive, so is it a max?
Yeah, say it.
Would it be neither?
Yes. Why is it neither, Ms. Wilson?
Because it's at 0 and isn't. This is where I'm getting confused.
Okay.
I know it's neither, but I don't know why.
Okay, remember that yesterday and also 2 days ago as well, we said that for f to have a min, the derivative must change from what to what? For you to have a min, the derivative must change from... No, that's not negative to positive. Do the visual in your head, guys. Look, my slopes, I'm decreasing and I'm increasing. So my slopes are negative and then my slopes are positive. I'm talking about the slopes of f. So that's the same thing as saying f prime. F prime changes from negative to positive. That's how you get a min. Yes or no?
Is that a point of inflection?
No. Well, that is a point of inflection on f. Yes, you're right. But we're not there yet. If the f prime of the derivative changes from positive to negative, that's a max. Does that make sense? Does my derivative change signs or change from negative to positive or positive to negative? No, it goes from it goes from positive to positive because I'm above the x-axis. This is f prime. This is f prime. My derivative does not change signs at x equals 6. Are we clear? So you're going to put f has neither, since f prime does not change signs at x equals 6, period. Perfect. Full credit. If you want to be more specific, you can say f prime. Actually, no, this is specific. F has neither since f prime does not change signs at x equals 6. X has neither at x equals 6. Well, you would have gotten the full credit because that's what they're asking at 6. So, but it's always good to be as specific as possible at all times. Yeah, not the ocean, but specific, not Pacific. Cool or not cool? Okay, are we okay, guys? Yes. Okay, look at letter B. What open intervals, if any, is the graph of f concave down? Give a reason for your answer. So it wants f, not f prime. So where is f concave down? Where f prime is decreasing or where f prime is negative. I think that year both solutions, actually, did I grade this one? No, I didn't grade this one. But I do have the rubric of all the analysis. I think they gave you credit if you set the second derivative, but it's always best to reference the one that they give you. So wherever f prime is decreasing, where is it decreasing from? Well, I'm decreasing from where? To 0, and then again from, no, not -4, 4 to 6. And remember, open intervals. So you're going to say f is concave down on parenthesis -2 comma all the way to what? 0 parenthesis and on from what to what? 4 to 6. Since f prime is decreasing on these specific intervals. And there it is, guys. Full credit. How do you feel so far? Heck yeah, look, this is from last year's exam, guys. From last year's AP exam. Oh, I didn't mean to lower it, but that's fine. It is from last year's AP exam. It was question number 4. Let's see if we can do letter C. So, Let's see. Hold on. Let's don't freak out. It says find the value of limit as x approaches 2 of 6f of x minus 3x over x squared minus 5x plus 6, or show that it does not exist. Justify your answer. First and foremost, do I know what f of 2 is? Remember the information they gave us in the very beginning. Did they give us f of 2? F of 2 is 1. So then I say, I wonder what happens if I plug in all those values and see. Let's see what happens. So I'm going to write limit as x approaches 2, and I'm just going to work on the numerator right now. 6f of x minus 3x equals 6, and I'm just doing direct substitution, times 1 minus 3 times 2. Does everyone know where I got that 2 from? Yeah, the x value is 2, right? So let's see. I get a 0. Okay, I'm going to check the denominator because something funny might happen if I get 0 over 0. What can I use if I get 0 over 0? Yeah, let's see if I get that. So I'm going to substitute 2 into x squared minus 5x plus 6. And let's see, 2 squared minus 5 times 2 plus 6. 2 squared is 4. 4 minus 10, that's negative 6, plus 6, that is definitely 0. Because I have 0 over 0, and because f of x is differentiable, therefore it's continuous, I can use what? L'Hopital. It's always good to state that. Since f is differentiable and continuous, comma, and since limit as x approaches 2 of 6f of x minus 3x over x squared minus 5x plus 6 is of indeterminate form, comma, I may use L'Hopitals. You probably got the credit if you didn't say all that, but it's always good to say it. You haven't said anything wrong. Are we okay? All right, let's use L'Hopital's rule. What does L'Hopital say? The derivative of the numerator divided by the derivative of the denominator? What's the derivative of the numerator? 6 f prime of x minus 3 over, what's the derivative of the denominator?
2x minus 5.
Okay. Now I definitely do not get 0 over 0 because if I plug in a direct substitution 2 into the denominator, 2 times 2 is 4, 4 minus 5 is negative 1. So if you get a 0 over negative 1, that's just 0. You can't do L'Hopital's anymore after this. Sometimes you have to do it 2 times, 3 times. All right, here we go. Do I know f prime of 2? Yeah, I know. Don't I have the graph of f prime? What's f prime of 2? Yeah, 0. So I have 6 times 0 minus 3 over 2 times 2 minus 5. So that's negative 3 over negative 1. So I get 3. You know what? We'll look at the rubric to see how we fare. Letter D. And we're not going to do this one, but let's just read it. Find the absolute minimum value of f on the closed interval negative 2 to 8. Justify your answer. Okay. Let's just look at it. Don't worry, we're not gonna tackle it just yet. Absolute minimum value. This is f prime. So think about f. So right now I have started an endpoint and f goes up, increasing because f prime is positive. So this is a min, a local min. It could be absolute, and then I go down. Then f goes down because f prime is negative all during here. Okay, that's not a min. Why did you guys stop me? Hold on. I have an endpoint. And I go up. Oh yeah, no, it is a min. It is a min. Sorry. Then I have. Sorry guys. I didn't mean to. Does everyone understand why I have a min at negative 2 for on f? Because it's an endpoint, and I immediately start increasing. Does that make sense? And then, so that's a candidate. Is negative 1 a candidate for a min? Say no. No, because my derivative is changing from positive to negative. Do you guys see that? So I have, that's a local max. Well, it could be an absolute, but no, it's a local max at negative 1, so that's not a candidate. And then let's see. What about at 2? Is that a candidate for absolute min?
Yeah.
Yes, that's a candidate because that's another local min. And then I go up, I go up, I go up. Let me go back to red. I go F is increasing, 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 increasing. Horizontal tangent, increasing, 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 increasing. Is 8 a candidate for, what do they want? Min? Absolute min? Is 8 a candidate for absolute min? No. That's probably your absolute max. Because you go up all that time. So your only candidates are at -2 and at 2. And then we'll talk about how we calculate that value later on. You can probably already figure it out now if you think about it a little bit. But do you see how it's done? Okay. All right. I feel like we're good. We kind of got the concepts. Now you just need experience. I wanted to do a matching activity with graphs, but I'm going to save that for tomorrow because I want you guys to get algebra experience and to get experience with the delta. So let's go ahead. Let's finish the delta today. And then make an attempt on UH Quiz 12 Extrema. And I didn't add it in here, but I'm going to go ahead and add it. At UH Quiz 13, it's called concavity. Make an attempt on Quiz 12 if you can today, please. And then make an attempt on Quiz 13 by tomorrow.
Wait, so quiz 12 and quiz 13.
Yes. Is that fair? Okay, what's up?
Didn't we have another
Test 1 derivative.
Test 1 derivatives. It's not due to the last day of the semester.
Okay.
Oh, really?
Yes.
Oh my god.
All right, guys, we're good.
What is that?